This is lesson number 2.4 out of the Intro to Algebra book. If you're in my class, the notes are starting on page 70. And lesson 2.4 is titled Evaluating More Formulas. So we're going to take the skills we learned in 2.2 and 2.3 and 2.2 and 2.3, and we're going to apply them to new formulas you haven't seen yet. So they're ones that you will see often as you move through your next 2 years or so of learning algebra. And so they're good ones to get started with here. Let's do our warm-up first. Warm-up. Warm-up. Problem number 1 says, find the perimeter. Find the perimeter of a rectangle using the formula P equals 2L plus 2W. That's 2 times the length plus 2 times the width. We learned this one in 2.3. When L equals 1.5 and W equals 3.2. All right? Okay, and the second one is find the value of a squared plus k when a equals 5 and k equals 7. Remember, this is evaluating. Plug it in and do the math. And number 3, find the value of 20 over 50 as a decimal. Have to remember how we convert fractions to decimals, huh? Okay, so those are your warm-ups. Let's write down our I can statement. This is what we'll be accomplishing during this lesson. I can use formulas in a variety of situations. Okay, I meant to put this I can statement on one line. I hope I got enough room under here. We'll see what we can do. All right, I'm using my dark green pencil to mark off that that's the end of our warm-up phase, and I have my one sheet that I'm gonna put right here in our usual upper left position. You can fast forward through me gluing if you'd like. Excuse me. formulas. Oh, not blue. Blue. All right, so on this little sheet, we have 3 new formulas that we are using, and they're the first one you might have seen before. The other ones are probably all new to you. The first one is called the formula for distance, and this is one that you'll wind up memorizing because you'll use it a lot. All right, so I'm just going to, with my pink highlighter, highlight distance. That's what we've got here. And then with my green one, I'll highlight the actual formula. D equals R times T. What the D stands for the distance, how far something is traveling. R stands for the rate, that's how fast it's traveling. And T stands for time, that's how long it was traveling for. Right? We'll go over that quite a bit. All right. So let's take a red pencil, and I'm just gonna circle the D and underline distance. Circle the R and underline rate. Circle the T and underline time. I had a student, and we still tend to memorize it this way, that the distance formula, when I ask, what is the formula for distance? My kids will often say, dirt, because the DRT reminds them of the word dirt. And I like that, because, you know, it's a way that makes it easy for them to remember. D equals R times T, DRT, all right? Okay, the next one is the formula for calculating a batting average. Now, admittedly, this is not one you are likely to ever use unless you are a very big baseball fan or somehow involved in the sports industry, in which case you probably have computers that do that for you. But I suspect they put that one in here because they want you to get some practice at using a formula that involves a fraction. So, when calculating a batting average, the capital B here stands for the actual batting average. The H at the top stands for the number of hits the batter got. And the A stands for at-bats. That's the number of times the hitter went up to bat. All right? And those are the 3 things you need to calculate a batting average. All right, and then this last one, now this one is one that you will use a lot in math. It comes up quite often. It's it's the formula for simple interest. It's how to calculate the interest you will earn on the principal, the money you put in a bank. Now, we're going to talk about this because I find that students at this age don't really understand how what these terms mean and how they work together. So let's just circle and underline first. The P in this formula stands for principal. The R in this formula stands for the interest rate that's being charged or given. And the T is the amount of time the money was left in the bank. Okay, so let's talk about what banks do with your money, because in order to understand how this interest formula works, you need to understand what it is they're doing with your money. So let's write up here. We're going to do quite a bit of writing right in this space here as we write out a short story of let's talk about what banks do with your money. All right, let's talk about what banks do with your money. All right, so I'm going to get my regular pencil and my red one, and we'll get it all down. Okay, so here's how it works. You put your money oh, hold on, let me fix that. You put your money in the bank. Write small to make this all fit, guys. Okay. You put your money in the bank. The amount you put in is called principal. Okay, the amount you put in the bank is called the principal. That's the P portion of this I equals PRT, the principal. Principal is the amount of money that you put into the bank. All right, so then the bank uses your money while, oops, not white, while they have it. Okay, the bank uses your money while they have it, and for that privilege, they pay you a small amount. They pay you a small amount that is called interest. This small amount of money that the bank is paying you to use your money while you've given it to them, that small amount of money they pay you is the interest. That's the I, the capital I here of this formula. Okay? All right, so the amount the bank pays you is a percentage. I'm going to abbreviate that. Is a percentage of the money you put in. This is the rate. So the percentage of your money, that's how they calculate what they're going to pay you, is the rate. And that's the R portion of the formula, the rate. Now, how much money the bank actually, how much the bank actually pays you depends on how long you leave the money in the bank. That is time. Time, that's how long you left your money in the bank. Okay, and that's the T portion of the formula. All right, so let's read this one more time, get it all into frame. All right, it's important to understand how this works in order for you to be able to understand how the formula works. All right, so what do the banks do with your money? You put your money in the bank. The amount you put in is called principal. The bank uses your money while they have it, and for that privilege, they pay you a small amount. That is called interest. The amount the bank pays you is a percentage of the money you put in. This is the rate. How much money the bank actually pays you depends on how long you have the money in the bank. That is time. All right, so that's how the IPRT of the simple interest formula, that's how it works in this banking system. All right, and I know this is a lot to write, but it's important for you to understand how this works in order for you to be able to apply this formula, particularly to word problems when we get to that point. Okay, all right, so take the time to write this out. You are probably going to need to refer to this if you're not already really familiar with how this works. You're probably going to need to refer to this when you get to word problems. All right, so let's get on to our second page of notes where we use these formulas, these new formulas we're learning about in examples. Okay, so the first problem that we'll do, and sorry guys, there's just no way around it with this lesson. There's quite a bit of writing. All right, the first one is Jerry biked for 1.5 hours at 18 miles per hour. MPH means miles per hour. All right. All right. And now the question is, how many miles did he bike? Okay. So which formula do you think we're going to be using here? It's going to be our DIRT. It's the distance formula. All right. So the first step when working with formulas, as always, is to write out the formula. So we have D equals R times T. I'm just spacing them out a little bit so I've got room underneath to plug in our values, which is, of course, step 2. Step 2 is to plug in any known values. Now, I say known values because I don't yet know what distance is. That's what we're trying to figure out. How many miles did he bike? That's the distance. I do know the rate, though. It says he was biking at 18 miles per hour. So I'm going to put 18 under R for rate. It says that the time was for 1.5 hours. So I'm going to put under T 1.5. That's the amount of time he was biking. All right. Now, next step then is to calculate, do the math. So let's see. 18 times 1.5 is 27. And it's not just 27, it's 27 miles. That's the distance. You could even bring down the D if you like. Distance equals 27 miles. So this is a word problem. We need to answer in a sentence. Jerry biked 27 miles. That's our answer. So that's how we apply the distance formula. And the distance formula is pretty simple. But it's good to get to know it well. As I said before, we will use that formula a lot. Okay, so let's see. The next one. Problem number 2. Let's put this up there. Vinny deposited $1,400. Deposited means he put it in an account for 3 years. Oops, not one period there yet. In an account for 3 years at 9% interest. That's the rate the bank is paying Vinny. 9% interest. Right? How much money did he earn? Okay, how much money did he earn? All right, so hope you figured out by now the formula we're using on this one is the simple interest formula. So it starts by step 1, writing the formula. And the simple interest formula is I, interest earned, equals P, principal, times R, that's the rate being paid, times T, that's how long you left it in the bank. All right, so step 2 is plugging in known values. We're trying to figure out how much he earned. That's this interest here. So we don't know that. But the principal is how much he put in the bank. And we know that. That's $1,400. So I'm going to put 1,400. And we're going to multiply that by the rate he is earning. Now we need to multiply that by the rate he is earning. But it is very important to understand, and this is a mistake that I see students make, you cannot multiply 9% in the percentage form. Can't be done, all right? So if you put down here 9 and then continue with putting your time in, you will not get the correct answer. That doesn't work. 9% needs to be converted into a decimal first. And remember, percent means per 100. So there are 2 zeros in 100. That means we have to move the decimal from where it's at, which is right here, 2 places to the left in order to get our decimal. All right? So the decimal equivalent of 9% is 0 and 9 100ths. So 0.09 is the decimal equivalent of 9%. That conversion you must make every time you use this formula. You cannot just put 9 in there. That is not the correct math. That percentage has to be converted to a decimal. All right, now multiply it by the time he left it in there. How long did he leave it in there? For 3 years. All right, so now we're down to the third step where we have to do the math. All right. So the first thing I'm going to do, I'm just going to bring down the 1400 and do the math of 0.09 times 3, 9 hundredths times 3, and that equals 27 hundredths, 0.27, right? Now I'm going to multiply 1400 times this decimal, and I get 378. 378. All right. So our answer is that Vinny earned $378. Don't forget the dollars. Got to have our label on there. There's the answer. All right. So the biggie on this one needs to be learned is this conversion. When they tell you what the rate is, they will always tell you the rate in the form of a percentage. So that percentage has to get converted into a decimal when it's time to do the math. All right. So let's write that note here. You can't multiply a number in percent form. All right? You can't multiply a number in percent form. You must convert to decimal. All right? You can't multiply a number in percentage form. You must convert to a decimal. So I'm going to make this into my thought balloon here and connect it to what you see here to what you see here. Okay? That conversion has to take place. All right. Last one, number 3 in our notes, is working with the how to find the baseball average, batting average in baseball. All right, so a baseball player had 28 hits during 80 at-bats. That's how many times he got up to bat, called at-bats. Okay? So 80 times he went up to bat, and out of those 80 times he went up to bat, he got 28 hits. 28 of these 80 times he hit the ball. All right? So, what is his batting, and I'm going to abbreviate here. AVG is the abbreviation for average. Okay? What is his batting average? All right, well, step 1 is to write the formula. Okay? So the formula is B equals hits, that's the H, over at-bats, that's the A. All right? So we need to then do the math. So B equals, how many hits did he get? 28. 28. How many times was he at bat? 80 times. Okay? We're filling in the known values now. That's our, whoops, wrong pencil. That's our step 2, known values. All right? Now step 3 is to do the math. You're going to have to remember how you set up a long division problem and divide 80 into 28. That means 28 divided by 80. Remember, you have to add put down a decimal and add zeros until you get a number. I can tell you that if you do the math, you will get 35 hundredths. Okay? That's what you'll get. All right, so batting averages, unless you're a sports fan, unless you're a baseball fan, you're not necessarily going to know this, so let me tell you. Batting averages are always expressed to the thousands. So if I was to tell you what this player's batting average is, I wouldn't tell you that it was 0.35, okay? I would tell you that his batting average is, and often they don't even say the decimal. This one, they would say that his batting average is 350, all right? Which is not real good. All right, so let's convert that in our final answer, okay? So his, let's make that note. Where did my pencil go? Here we go. So, batting average is always expressed to the thousands. So in this case, our answer sentence would be, his batting average is 0.350. Okay, that's how we would put it. Now, let's go ahead and circle in red the answer. And then with my green highlighter, I'm just going to thought bubble this little note here. And make an arrow to what we got as an answer and how we converted that for the answer sentence. Okay? All right, so that's the notes for lesson 2.4. Let's go ahead and move on to the practice problems. Okay, so practice problems for lesson 2.4. Pretty much just like our notes. We're doing one problem for each one of the new formulas that we're learning in this lesson. So there's problem number 1. Jackie deposited $500 in an account for 10 years at 6% interest. How much did she earn? Problem number 2. Irina drives at a speed of 55 miles per hour. She drives for 3 hours. How far did she travel? And problem number 3. Did I say 3 last time when it was 2? Maybe I did. Anyway, all right, problem number 3 is Willie has been up to bat 74 times this season. He has 21 hits. What is his batting average? All right, so on each one of these, you can just pause on them and work them out. And now I will go through how we would solve these problems. All right, so Jackie deposited. This is obviously going to be a simple interest formula. So first step is to write down the formula. I equals PRT. All right, do I know the principal? Yes, she deposited $500. So I'm going to put that down there. Do I know the rate? Yes, it's 6%. But remember, I can't put 6 down here to multiply. I have to convert that to a decimal. So that converts to 0.06. All right. And how long did she leave it in there? Time. She left it in there for 10 years. All right. So now we do the math. I'm going to bring down this 500 and multiply these two first. Because I'm multiplying by 10, it makes it very simple to figure out, what is 0.6 times 10, because I just have to move the decimal one place. So the answer is 0.6 or 6/10. All right? And again, pretty easy what my answer is, because I take the 5 and the 6 and know that that's 30 and move the decimal appropriately. So we've got 300. 500 times 0.6 is 300. So the answer is Jackie earned $300. All right, Jackie earned $300. All right, simple interest formula. Okay, let's look at number 2. Number 2 says, Irina drives at a speed of 55 miles per hour. She drives for 3 hours. How far did she travel? All right. All right. Well, this is obviously going to be a distance formula. It's time for dirt. So first step, write down the formula. D equals R times T. All right. What's the rate? She was driving at 55 miles per hour. So 55 times time. How long was she driving? She was driving for 3 hours. 55 times 3. Now do the math. 55 times 3 is 165. All right. So Irina drove. Oops. She didn't dove. She drove. Irina drove 165 miles. That would be our answer on that. Okay. All right, and the third one. Okay, Willie has been up to bat 74 times this season. He has 24 hits. What is his batting average? All right, so we are talking about batting average formula. B equals H over A. All right, so let's plug in our known values. H is how many hits did he get? It says that he got 21 hits. So 21 over how many times he was at bat? That was 74. Right? So you'll need to, out on the side, do some scratching to find out what 21 divided by 74 is. But I can tell you that that comes out to 284 thousandths. All right? So Willie's batting average, I'm going to put it down here. Are we still in frame? Oh, good. Willie's batting average is 284. Well, that's how they would say it, but we wouldn't read that number that way. All right? That's the answer to problem number 3 in our practice problems. Okay, so that's practice problems. Let's take a look at our worksheet for lesson 2.4. Worksheet is divided out into problems, simple interest problems, and they tell you what the formula is, distance problems, and then batting average problems. Okay, so you don't have to guess which formula am I supposed to use, though it's usually pretty obvious, I think. But on the worksheet, they're telling you, and they're giving you the formulas. Still, remember, the first step is always to write out the formula, plug in the known values, and then do the math. If you don't think you can fit that in the space here on the worksheet, which I would understand, then use a second sheet of paper and copy your final answers over onto the worksheet. All right? Okay. Oh, and when you're doing the simple interest ones, the big one here is, remember, do not plug in 5 for the rate. Convert that percentage to a decimal. All right, so last then is our exit ticket. Exit ticket is for extra practice, or your teacher may use it for something else. I don't give the answers to these. If you'd like to work them out, you may pause here. All right, so that's the end of lesson 2.4. Remember, the only way to learn math is to do math, and mistakes are proof that you are learning.